Hello and welcome everyone. My name is Peter Robinson and this is the Ethereum Engineering Group Meetup. So today we've got Tim Beiko from Ethereum Foundation who's going to talk about Ethereum governance. So Tim, please introduce yourself.
Sure. So, hey everyone, my name is Tim. As Peter said, I work at the EF. Previously worked at Consensus on the Hyperledger-based client team. And the main thing I do today at the EF is run what are called the All Core Devs calls, which is the forum where people come and discuss potential changes to Ethereum. So yeah, today I'll sort of walk through how the entire governance process of Ethereum is structured, how it works, and sort of what we're thinking about going forward. And yeah, happy to take questions after if we have time as well.
For sure, that sounds awesome. So thank you, and so please present your slide. Should we ask questions at the end or at the end of each section? When would you like?
I'm happy taking them as we go. I won't see the Zoom chat, so I'll pause a couple of times, and then Peter, if you can keep an eye on the Zoom chat and just surface whatever comes up there, we can go that way. Yeah, I think I'd rather we get them done along the way so that people can follow along.
Sounds good.
Sweet. Okay, so do you see my slides?
Yes.
Awesome. Sweet. So Ethereum governance. So I think the first thing when we're talking about Ethereum governance, it's important to define what are we actually governing, and you know what does that represent. And I think there's really two things here that we're referring to. The first is like the set of protocol rules for Ethereum. So Ethereum is obviously a protocol, and it has kind of two types of protocol rules, some which every single implementation must agree to. And if you don't agree to those, then you're literally segregated from the rest of the network. So we call these the consensus rules, and they're written in things like the yellow paper, like the Python specifications and whatnot. And then we have another set of protocol rules that are, you can think of them as nice to haves, where there's things that help a certain Ethereum implementation communicate with the rest of the network. But if it's not there, it doesn't necessarily produce a different result given the same transactions. So things like the syncing algorithms, the way the RPC endpoints are exposed, how execution and consensus layer clients communicate, all of that stuff is effectively like our first chunk of things. So here, these are all of the consensus rules. These are all of, or not all, but some examples of the non-consensus protocol rules. And then the other thing that we sort of implicitly imply when we talk about governing Ethereum is we talk about governing like the Ethereum mainnet chain. So you know, Ethereum is just a set of protocols. You can deploy it in many contexts, but in practice, when people talk of like Ethereum governance, they refer to like the chain with chain ID 1, which has, you know, everybody's Ether balances, all of the applications deployed on it, and whatnot. So those are really like the two things that that we're concerned with here. And so the bulk of this presentation is about who governs Ethereum and how. Because this is a question that I think a lot of people have, and is hard to answer extremely concisely. So we can have a long chat about it. But the best way to think about it, I think, is kind of like an onion, where the closer you get to the core, the more formally defined the things are, but the more narrow the domain of influence or execution is. So obviously at the very center, we have like the protocol itself. And then if you sort of cycle out, you have this group known as core developers. Then you have people who push forward changes, which are called EIPs. Then you have all of the nodes that participate in consensus directly, all of the nodes that participate in consensus indirectly, all of the users of Ethereum, and then the community as a whole. So we'll sort of walk out through each of these steps, but this gives you like a full picture of the different actors that are involved in the process. So to start, core dev. So this one is in scare quotes because it's a hard thing to define. And I have this picture here. This is Afri, who's one of the core contributors. There was another ecosystem that wanted to very formally define what a core dev was. And he goes in this comment and very eloquently goes through all the reasons why this is a bad idea. And in short, there's value in having like kind of a porous set where people can come in regardless of the company they work for, regardless of if they work for a company, and be able to like contribute and participate in this discussion. So in practice, we have all of these different client teams. We have academics, we have people who work for venture capital firms, large companies, people that are anonymous that we have no idea who they are. And a lot of people just end up showing up in the Discord. We have this Discord server for like R&D. And I have a few examples on the screen here to kind of highlight like the range of folks that come in. So there's like these 4 little circle avatars in the middle of the slide. The one all the way to the left is Danny Ryan, which works with me at the Ethereum Foundation. He leads most of our R&D work and also is very involved in protocol changes. And he just showed up, because Ethereum had this open process, sort of started learning about it, starting showing up to calls, and eventually helped work on proof of stake research. And now is sort of central to everything around Ethereum's consensus layer. So that's like an example that's it's kind of an interesting one where somebody who had no prior connections, like just found about this on the internet and is now like one of the most important contributors to the project. Next to that, we have this little green eye avatar. This is someone who's actually pseudonymous. Their handle is POTIZ. They also showed up on the Discord, had a lot of strong technical opinions about a lot of design issues with the beacon chain, and sort of started contributing part-time, and now has joined the Prism team and are a full-time contributor on Prism. And similarly, they had a real job in another field and created this anonymous avatar because they didn't want to tie their like previous professional identity to their little Ethereum side project. And now they've fully gone down the rabbit hole and contribute to Ethereum full time. Third one, this little pineapple with sunglasses, is a Proto Lambda. Proto is another example where a few years ago, the Ethereum Foundation had a lot of hard problems around proof of stake. So just put like an RFP for people to solve them. And Proto was somebody we'd never heard of that just showed up and solved one of the problems and sort of got really interested in it and went down the rabbit hole. And also someone who's contributed a ton to just getting the beacon chain launch, was one of the people who came up with the design for the merge, so the transition to proof of stake, and now works on layer 2s. So again, somebody who like we just put out a problem out there, they solved it, and then wanted to solve 100 more. And then lastly, this one is quite interesting, this sort of little fossil black avatar. This person, again, a pseudonym, I don't know the real name, but they're called Sea Monkey. And they're just enthusiasts who, while we were working on the merge, they started running every client combination on their personal computer to try and find not only bugs, but just things like UI glitches or whatnot, or finding that, I don't know, the Lodestar and Beiko pair had a weird issue with like some API thing. And they came there, they spent probably 4 to 6 months, maybe 2-3 hours per day, testing all the client combinations, reporting issues. And they basically left after the merge. So it was like a very different thing. So they came in, contributed, added a ton of value by finding these issues, and then sort of walked away, and I haven't heard from them again. And the reason I emphasize this is I think this sort of hints at the value of why you want to have an open and kind of vague definition for what a core developer is. Because if you have this super formal thing where it's like, oh, you need to work at Consensus or Nethermind or the Ethereum Foundation, then all of these people who end up being like extremely valuable contributors might feel put off by that and sort of never show up. So I think it's something we do that's a bit unusual with regards to just software development, but it works really well. And then the last thing I'll hit on here is we have all these places on the internet. So these YouTube channels, these forums like E3 Search Eats Musicians, where a lot of the conversations around protocol changes, protocol designs, new ideas sort of happen in public. And I think that's also been an extremely valuable part of like creating this environment where anyone can come in and contribute and feel like they have the same context as someone working at the Ethereum Foundation does. So this is like our first part of the process. So, these core developers, they're really focused on the protocol as a whole. They want the whole thing to keep moving forward, to keep improving. If you go out one layer, we have what are called EIP champions. So EIP stands for Ethereum Improvement Proposals. And this is the formal template by which you propose a change to the Ethereum protocol. So anyone can go to eips.ethereum.org and, create a new EIP, advocate for a certain change. And if you're a person doing that, then we call those people champions. You basically want to demonstrate that the change you're proposing is valuable for Ethereum, that it's technically sound. And then you want to create some momentum around it because you have to sort of convince everybody else who's working on the protocol that this change is worth doing instead of everything else they could be doing. And in practice, the bigger your changes, the more back and forth and collaborations you're going to have with people who work on client software, researchers and whatnot, because the larger the change, the more parts of the stack it'll involve. And unfortunately, there's no guarantee, even if you do all the hard work. There's no sort of checklist that if you complete all of this, your change will go live on Ethereum. If something else more important comes up, then unfortunately, it's possible we just don't do your thing and do the other thing instead. And under these bullet points, I have a couple images that sort of walk through the process. But in practice, what happens is somebody writes a new EIP, they present it to core developers, and core developers find a denial of service vector or a DOS vector in it. Like something about your EIP could just crash the whole network. And then so I have a little meme about that on the left. In the middle, I just searched on Ethereum Magicians for DOS, and you can see like all of the popular EIPs, whether this is the account abstraction one, the blob transaction one, have discussed denial of service vectors at length, prior to going live on the network. And finally, on the right, I have a screenshot of like a recent successful championing of an EIP. So if you see first in the title, you can see they tried for the Shanghai upgrade, they did not get in because there was more important stuff to do. So then they tried to get for Cancun, which was the next update, and then they did get into that one. And I think this one is really good explaining. Look, if you squint a bit, you see the bullet points. They implemented everything across all the clients, had a bunch of testing done. They had support from the Solidity team. They had support from a bunch of application developers and users for their feature, and effectively, did all of that work of proving the thing was valuable, proving the thing was sound, getting momentum within the community. Even that wasn't sufficient the first time around, but then, second time around, they managed to get their change in. And it's also worth noting the number on the CIP. So 1153, CIP was created, I think 4 or 5 years ago originally. So these are people who they saw an idea that someone had tried to bring to Ethereum 4 or 5 years ago. They had failed for whatever reason. So they sort of took this older idea and then spent another year or so trying to get it to a spot where it could finally be deployed. So it is quite a lot of work, but it is something where, there's a formal process that people can follow and sometimes successfully make a change to protocol. And so the main question that comes up around governance at this point is usually, if you have these client developers, these core devs that write all of the code for the protocol, and then EIP champions that come and advocate for change, aren't these the people who control all of Ethereum governance? And the short answer is no. And the reason for this is the rest of the onion. So if you look at like the protocol itself, the role of core devs, the roles of the EIP process, those are the things that are like the most formally defined as part of Ethereum. And then as you start zooming out, you have layers that are less formally defined, but end up becoming more and more powerful and can play a bigger and bigger role in the network's governance. So consensus participants is the next layer up. You can think of these as, well, in practice, either miners or validators. So proof of work, those were the Ethereum miners. Today, they're the beacon chain validators. And when there is a network upgrade on Ethereum, the only thing that client developers and EIP champions do is write the software and put it out there for people to upgrade. There's no mechanism as part of the protocol for it to like update internally without people manually changing the software that they run. So this means that at the very least, you need some of the consensus participants to run the software. Because if none of the stakers on Ethereum decide to upgrade their nodes, then the new version of Ethereum doesn't go live on the network. And then what happens on Ethereum is if only a subset of the consensus participants decide to upgrade, you get a chain split. And the way chain splits gets resolved in proof of stake on Ethereum is that the two sides of the network who disagree on what the rules of the protocol should be will start slowly burning a little bit of ether on the other validators, so the validators that are not agreeing with them anymore. And then once the other validators, or the validators on the side they disagree with, once their stake represents less than a third of the stake on whatever side of the chain can continue to finalize and move on from that. So it's kind of a subjective view of governance, where like every side of the network ends up, burning ether on the side that they disagree with. And this is like a pretty powerful thing where you need to get, all of this group of consensus participants to agree to a change. And if they don't pretty much unanimously agree, then you sort of get this chaotic situation where they're sort of competing against each other and in a weird way, like attacking each other's stake. And just to put this in practice, like what if like all the core devs just ran nodes and had all the validators and like control the chain? These numbers are like a month or so old, but I think it's still good enough. So if you think of like how much ETH the core devs have, a few years ago the EF announced we were giving all of the client teams a bunch of validators to run. So teams got around 144 validators. There's about 10 client teams, so think of that as like 1,400 validators. But maybe they have more in secret, right? These like hidden validators. So say they had twice as many or 10x as many. Like a worst case, they have 14,000 validators split amongst them. Today on Ethereum, there's about 600,000 validators. And this was like a month or two ago. I think the number's getting closer to 900,000 now, if I'm correct. So this means that as a whole, this entire set has somewhere between 0.1 and maybe 2% of the network. And as we saw earlier, you'd need at least 2/3 to be able to finalize the chain with some consensus change that you want. And then you could imagine, maybe the Ethereum Foundation decides to collude with these people. The Ethereum Foundation's Ether holdings are all on chain. So you can see there's about 320,000. That's an extra 10K validator that would have to be staked. So this is not Ether that's currently staked. But even with that, you get a pretty small percentage. You get to about 4% in the absolute worst case, making some pretty wild assumptions around how much hidden Ether all of the client teams have. So it's just worth noting that like core devs, they sort of write the software, they put it out for the world, but then it's really consensus participants who decide, okay, are we going to run this and update the version of the protocol that we support? But even in the case where all the consensus participants agree to do something, this is not like the final layer in sort of the governance process. The other thing we have on Ethereum, and that's really critical, is non-validator nodes. And this is why the centralization of the network is important. So a lot of times people talk about like stuff being decentralized and they sort of hand wave like, oh, it's just good if it's more decentralized. But for Ethereum specifically, the reason for this is that every single node on the network will validate every single block and the transactions that it sees in them. And as an aside, this is why validator is a very bad term for the nodes that put in 32 Ether and get the like proposed blocks. Because even if you just run a node without any Ether in it, you're also validating the correctness of the chain. You simply don't get the like proposed blocks and get transaction fees and whatnot. But if you run a node and you see a block that's invalid, say that the validators colluded and they decided to give themselves 1 million Ether or double the issuance or something like that. If only them are running nodes, then they can do this and sort of all collude together and no one will notice that. And the smaller your validator set is, the likelier this is to happen. And collusion is like the nefarious version of this, but you can just imagine a less malicious version, which is just they have a correlated bug, right? If you have 10 validators, they all run AWS goes down. Obviously, your whole network goes down. So the thing we get with non-staking nodes is that if we have many and many of them, and they represent like a super majority of the peer-to-peer network, if I'm a validator and I propose a block, I know that an invalid block will be rejected by all of the other validators and the non-staking nodes on the network. So because all of these nodes end up actually validating the transactions that they see. And this is why, for example, if you send money to a crypto exchange, you send some Ether to a crypto exchange, when they ask for confirmations, what they're doing is they're running their own node that's not staking, but they just make sure that your transaction actually followed the protocol rules. And they want to make sure that everybody else on the network agrees with them on that, and then they credit you your Ether to sell and do whatever on the exchange. So in a way, the way to think about like running your own node is you're sort of sharing your view with the entire gossip network of what the valid protocol rules are. And this is why it's really important. You want to have a large number of people that are able to do that, such that a small number of validators aren't able to like impose rule changes on the rest of the network. And so if you move one step above that, you have all the people using the chain. And the way this comes up a lot of times in discussions is like, if there's a fork on Ethereum, can a specific project decide which side of the fork would win? So to specify this a bit more, if there's a fork between Ethereum, there's like a difference in consensus rules. What happens is that the state of the network gets duplicated on both sides of this fork. By state, what we mean is that all of the addresses, all of their balance, so I have 1 ETH, you have 2 ETH, and so on, all of the contract code and all of the storage. So, like an NFT contract and who owns the NFTs, Uniswap and all the pools and whatnot, all of that gets duplicated on both sides. And there's some things that are able to coexist relatively well on two forks. So if you look at something like, ETH, the asset, we've had forks in the past, we have ETH and ETH Classics. They can just both kind of go along and you get your coins on both forks. And, the relative value between them will fluctuate, obviously. Or you can think of things like on-chain NFTs, where like all the data is actually stored on-chain. They can just sort of coexist on both forks, and there's a market that emerges around which one is the right one. But there are some projects that actually need to make a binary choice. So if you think of something like real-world assets, like stable coins, if you have USDC and the network forks, you might have 2 ERC tokens, but then which of those tokens allows you to redeem $1 in an actual bank account is a decision that has to be made by the issuer. Or similarly, if you have an oracle, right, where say Chainlink is reporting the price of ETHUSD, it needs to decide which price from a centralized exchange does it report to which Ethereum chain, to sort of set an on-chain network for that. And similarly things with bridges, right? If you're bridging into a layer 2, which deposit contract does like Optimism or Arbitrum recognize as the valid one? And so all of these applications end up being quite interconnected, right? You could imagine, taking some USDC, depositing it in Optimism and trading that for, some ETH on Optimism, whose price is determined by like a Chainlink oracle or something like that. And because of all this interconnectedness, there's like a huge network effect where everything sort of values staying together. So as a whole, if all of the projects decide to recognize one or another fork as the valid one, that's like extremely powerful, because they can say most of the value and most of the liquidity will actually move here. But it's extremely hard for a single project to do that. If it was just USDC or just Uniswap moving somewhere else, obviously it would kind of be chaotic through the fork transition, but it don't have like a sufficient power to then pull everything out, because all the rest of the state in the code is stored on both sides of the chain. So if everybody disagrees with, what USDC or what Uniswap wants to do, they can remain on their own chain and, obviously have that project leave, but everything else will sort of stay on their side. So again, this is something that's like extremely powerful and extremely informal in the way where like the conflict resolution would play out. And then the last and like most fuzzy layer is quote unquote the community. And again, this is in scare quotes here because it's very hard to define. But I think the way to think about this is if you think of Ethereum or even something like Bitcoin or the US dollar, it's like this shared concept to which we have like all these properties we agree to. And And when things are sort of going well, we can define these processes like the EIP process, like the formal stages of a network upgrade, to like govern these things. But then it's very hard when things get into the extremes to determine in advance, like, how are we going to govern things? If we have very contentious forks, if we have things like social slashing on Ethereum, you end up moving to like a conversation around the second order impacts of the change more than the change itself, right? Like for Ethereum, we want the platform to be credibly neutral. We want Ethereum to be relatively stable to applications developing on it, and so on. And so when we get these like very chaotic scenarios, it's extremely hard to coordinate because there's not really a right or wrong answer. What ends up happening is you sort of have this coordination around what the values are that you can or cannot break, and the resulting sort of outcome of that will be deeply sort of will deeply embed those values. And we've seen this, obviously on Ethereum with the DAO fork, and many other examples that I'll walk through a bit later. So hopefully this gives like a good overview of the different actors and like their roles in the system. I have a couple more slides and I'll pause for questions. But yeah, last thing on the actors is, why doesn't it feel like there's all these different stakeholders in practice? Like, it sort of feels like we end up much more towards the center of the onion, and we don't really get to like the outer layers that often. And I think my answer to that is like, the core developers try to listen to the other layers and will try to not push a contentious upgrade, because if things go wrong and the network ends up in this chaotic state, they're the people who sort of have to deal with the fallout of it and fix things. So in practice, you sort of see this proactive gauging of what changes should or should not be done. I'll pause here if there's any questions, but otherwise happy to keep going.
Yeah, no questions from
Okay,
me.
cool.
But so I think that yeah, and I think we've got a thumbs up. So I think you're all good. It's really interesting though. So yeah, please keep going.
Yeah, let's keep going.
I have a quick question.
Yes.
So Tim, I was interested, when we think of node operators that don't actually run validators, what would be the incentive for people to run a node operator? Because as far as I can see, it's only going to be an expense. There's no financial reward apart from the health of the network, really.
Yeah, there's two things, right? Like, one is like altruism. Like, I mean, I run a node just because it's like the right thing to do, but that's not great. The other thing is it does let you access the network permissionlessly, right? Like, if I run a node, I can submit a transaction or query my local copy of it without accessing something like Infura or Etherscan. And so like, altruism is like good. It's not like an amazing thing to rely on, but Ethereum does have like a fair bit of that. There's also some actors for who it's like sort of aligned with their business interests. So for example, I mentioned crypto exchanges earlier. They have to run nodes because they want to validate your deposits to make sure you're not like sending money you don't have or whatnot. And by virtue of doing that, like, they share their view of the network with everybody else. And yeah, in terms of just like accessing the network yourself, I think we've seen like it's easy to run a node and get like your latest Ether balance and through like vanilla JSON RPC. In practice, people want to do more than that. Like, when I go on Etherscan, I'm not just looking at my latest Ether balance. I'm looking at like all the transactions I did in the past and like all that stuff. That used to be really hard to do locally. Like, you need tens of terabytes of storage. But with clients like Aragon now, there's actually people who've built like the equivalent of Etherscan that runs locally on your computer using an Aragon node in something like 4 or 5 terabytes of storage. So yeah, the benefit you get is you get to just like permissionlessly access the network. But yeah, it's very hard, and there's no way to identify nodes as unique on the network. So we can't like incentivize it one way or another because people can just fake it. There's no way to like say what an actual node is. Yeah.
Yeah, that was my next question is, do we have an idea of the proportion of node operators that are actually not running validator nodes?
I haven't checked the numbers recently, but like I was looking at a crawler today that had about 8,000. I feel like we're probably at about 1-to-1 today. I think there's something between 4 and 10,000 staking nodes. So like the numbers might be off by like 1 or 2x here, but they're not off by 10x. So like there's roughly the same amount on both sides, maybe a couple like a couple times more on one side or the other, but not like 10x or 100x more on one side.
Yeah. Awesome, thanks. Yeah, I was just looking as far as this sort of whole concept of looking at the validator set sort of growing and growing, and the benefits of not having it quite as large as it is, because it's pretty much with once the activation queue is cleared, it'll be just over 1 million, I think.
Yeah.
Okay.
And one thing that is nice with Ethereum, like having a low node requirement in terms of hardware makes it easier for people to run validators. So it's like if you can get the marginal node period, that's good. So like and if obviously 32 ETH is not like a trivial amount of money, so there's like an economic constraint there, but you can run a validator on consumer grade hardware, which is like a valuable property of Ethereum. And if you have the consumer grade hardware, you can choose to run the validator and get paid, or not run the validator and be altruistic but not get anything in return. So it is, if you compare it to other blockchain networks, sometimes they'll have like in the dozens or the hundreds of validators, but Ethereum has like hundreds of thousands on chain, but they are single digit thousands of actual nodes, which is still a large number.
Yeah. Thanks, Tim.
Of course. Any other thoughts, questions? Happy to move on or take them now if there are. Okay. Okay, so moving on. I have a couple examples of some of the most contentious or like high stakes changes in Ethereum history, and sort of how they went down from a governance point of view. So the first one that always comes to mind is the DAO. So for people who aren't familiar, this was in 2016. Ethereum's most popular application was effectively, think of it as like a VC fund on Ethereum. And it was so popular that about 15% of all Ether was deposited in the smart contract of the application. And one day that contract was hacked. Somebody was able to start stealing slowly all of the money from the contract. And so there was this big debate within the community. Should we recover the funds from this contract, or should we let the hacker sort of walk away with all of the money, because effectively code is law, and the hacker didn't do anything that the protocol did not permit them to. They just found a bug in the implementation of the contract. And this had the community quite divided. So what Klein developers did there is that they took a somewhat neutral stance, where in their software releases, they had a flag and they let users decide whether or not they wanted to activate the upgrade and support it. And then, when the network hit the upgrade time, part of the network had decided not to support it, but the majority had. And so Ethereum Classic exists today, and this is where this fork came from, where Ethereum Classic is basically the set of nodes that decided to not run the software upgrades that client developers put out. And I don't know what the percentage today, the market cap's maybe, 1% of Ethereum. Like most of the activities migrated to Ethereum, but it was like a non-trivial part of the community at that point that sort of went there. And then a year after that, we had another huge hack. So we had the parity team had this multi-sig, which was the most used multi-sig at the time. It wasn't as widely used as like something like Gnosis Safe is today, but in those days, you could think of it as the equivalent of Gnosis Safe. And there was a bug where all of the funds and all instances of this multi-sig got completely bricked. And the parity team had recently had a large fundraise event where all of their money was sitting in that and was now inaccessible. So this was another huge hack, not quite as big as the DAO, but still in the billions of dollars total. And it sort of affected one of the Ethereum co-founders. So like the CEO of Parity was one of the co-founders of Ethereum, and they were also one of the largest client implementations at the time. So we had the Go Ethereum client, and then the Parity one. A couple smaller ones were starting to emerge, but Geth and Parity were basically the two ones that mattered. And this is something where, it's hard to think of a hack that would affect insiders more than this, when it's the literal co-founder of Ethereum. They have the second most used client, but it was huge pushback in the community. I think after this decision was made for the DAO, people saw the sort of ripple effects that it had around like the neutrality of the platform and whatnot. So when this other hack happened, the community was much less willing to actually pursue ways to fix it, even though there could have been, technical approaches that were quite minimal and would have restored things. And so in this case, this EIP 999 was the proposed solution to this hack. The client developers never even proposed it as part of an upgrade, even though one of the team was strongly in favor of it. And then because like the community opposed it so strongly. So this is quite interesting because, one, having multiple client developer teams clearly shifted things there, where if there was only one, their software upgrade would be equivalent to Ethereum software upgrade. So the fact that there were many meant that like this team had to convince the other ones. And then two, this is clearly a case where like, from a technical perspective, there wasn't anything complex or whatnot to do. It was really a decision by the community to not want to make this change to the protocol. And then a few years later, there was this other change, EIP 10.15.7, called ProgPow, which was a change to how the proof of work algorithm worked on Ethereum. So when Ethereum launched, it used a different proof of work algorithm than Bitcoin, with the goal of having it be ASIC resistant, because a huge ASIC market had developed on Bitcoin and people wanted to keep Ethereum mining more decentralized. But then, a few years after that, we started to see ASICs appear on Ethereum as well. So they built better ones that were suitable for this. And so there was this proposal, ProgPow, which would basically break all of the ASICs and make it even harder to create ASICs to mine Ethereum. This is something where I think it was very contentious as well. And I'd say core developers were maybe like weakly in favor of it as a group. But again, this is something where the community was quite opposed. So the community didn't like the idea of sort of picking winners and losers in like the mining market, and didn't feel like the evidence that ASICs were doing anything harmful on the network was strong enough. So this is another case where you had a change that client developers probably, favored at the margin, but then decided to never include as part of the upgrade because of community pushback. And then my last example here is the merge. So Ethereum's transition from proof of work to proof of stake. So this was obviously something that since the launch of Ethereum was always sort of planned, but got delayed over and over and over again. And this is something where by that time, like by the time where we were ready to ship it, most of the people, or the overwhelming majority of people part of Ethereum, were sort of in favor of this change. But there was one huge set of stakeholders that wasn't, which were miners. So effectively, most miners were against it because it destroyed their mining business. A few of them had, transitioned to staking or had other investments in Ethereum, so like they weren't necessarily super opposed. But for a subset of them, it was clearly like a net negative change. But because the community support was so strong, this is an upgrade where client developers added a ton of technical complexity to the transition such that it wasn't dependent on miners to activate. So miners could not like stop the transition. And because of that, so the community support for it and sort of the technical work around not letting like this group of stakeholders sort of block the update, we were able to transition. There's this tiny minority fork that emerges as a result called ETHWork. I say it exists on this slide, but someone sent me a link this week to say their website was down, so I'm not sure if it even still exists. But I think this is something where like even more than Ethereum Classic, like basically the entire community moved to proof of stake. Even though for some group of the community it was quite contentious. And so if this was sort of, like the past of governance and like the hard things we went through, I think looking at where we're at now and how things are evolving in the future, one thing that's happened in the past couple of years is like there's way more people now who care about what direction Ethereum goes because they've built an application or infrastructure on top of it and also want to contribute back. So there's more and more people that are like involved and stakeholders in the process. The other thing that's happened is we only have what I call high-hanging fruits left, where a lot of the obvious, easy, no downside improvements we've done in the past. Today, when we talk about like big protocol changes, they often involve pretty complicated trade-offs where a reasonable person can like argue both sides of it, and so there's more time spent debating stuff. And so if you combine those two things together, the default path you get is like more people to align on more complicated decisions, and that's where it gets you to a spot where like you just end up ossifying, right? Like you end up being slower and slower and changing the protocol. And I'm not saying like this is the path we will end up in, but I think this is like left unchecked. This is like the emergent outcome of the way our process is structured. And I think this is something that like is very important for the community to think through. Like, is this an outcome that we're happy with? There's pros and cons to this, but it should be something that we actively decide rather than something that sort of ends up sneaking up on us. And we sort of realize 5 years from now, oh, we're in this like equilibrium that we somehow can't escape because we just sort of didn't realize it was happening. So in the meantime, while we don't have answers to like the really hard questions, there's a few things the people I work with at the EF have been working on to try and make the process of thinking through this stuff easier. But one is just from a very technical perspective, aligning how Ethereum's execution and consensus layers are specified. So they used to be extremely different. Execution layer used like the yellow paper, consensus layer used Python, execution layer had like EIPs to specify changes, consensus layer had none of that. So we've moved to a spot where now we have a Python specification that's complete on both sides. This summer, the consensus layer people started using EIPs to describe their changes and reference their Python spec, but at least have like a clear identifier of changes. So it's been good to like at least move to a spot where there's a coherent approach to how Ethereum is defined. And then related to that, there's been basically EIPs on Ethereum tend to focus on like core protocol changes, and we have this whole other class of standards called ERCs, which tend to focus on application level changes. So think of something like ERC20, right, which is just a standard for a token on Ethereum. And historically, these things have all been coupled together. But as both sides of the community grown, it became more friction to just manage a single process for both sides and both groups. So what we've done is, and are still working on, is this idea of EIP working groups, where we've managed to sort of split the process for not only layer one consensus changes, which are EIPs, and then all these application standards as ERCs. But now we have a new one, RIP, so roll-up improvement proposals, that's aimed to getting layer twos to standardize stuff amongst themselves. So I think this is another thing where like having similar looking processes, but that can diverge based on the needs of these different groups, helps them kind of be more useful to those groups. Then much more speculatively, so the EF has funded a group of 30 researchers over the summer in an initiative called Summer of Protocols, where we got people thinking about a lot of big problems and questions around protocols, not just within crypto, but across a whole host of domains. So we had people from architecture, people from the arts, people who work in workplace safety protocols, all think about like some challenging issues around protocols in the fields they work with, and to try and figure out other like commonalities in how you steward and manage protocols. So I encourage, if people are interested in that question more generally, summerprotocols.com is where there's information on that. And we're actually launching or announcing sort of our research outputs next week. We'll have a virtual event for that. I I should have linked it in these slides, but if you want to attend that, just send me a note. I'll have my email on the last slide, and I'd be happy to have you. But yeah, this has been just a research project around, can we try to understand protocols as a class better so that when we think about Ethereum, we have some better theoretical frameworks to do so. And I think lastly, the last big question in terms of governance that we still haven't quite approached and found like a good path forward with is, how do we think about applications that scale and become huge on Ethereum and the impacts of that on layer one? Like we've had a lot of people, over the past couple of years talk about things like Lido, talk about things like Flashbots, talk about things like USDC, talk about things like Eigenlayer. And when applications get really big, they can start to sort of influence the consensus of the protocol in subtle ways. And while we can come up with like solutions to like one-off issues there, I don't think we've like found a good approach to like the generalized version of this problem. Like, what does it look like for an application to like grow on Ethereum, and how do we handle that? So I think this is something where having more people spend time thinking about this in the next couple of years is extremely important. So that's all I had. I have a couple of slides after this with some of the information around this meetup. But if anyone has questions now or in the future, you can reach me, tim@ethereum.org. I'm at Tim Beiko on Twitter, Telegram, GitHub, pretty much any platform. You can reach me there as well. But yeah, happy to take some more questions. Actually, before I take more questions, there's future talk slides and some links. So I'll just go quickly over the future talks, and I'll leave the links if we have questions. But December 20th, Solidity Interview Challenge by Peter. January 17th, Decentralized Sequencer Friendly Consensus Algorithms for ZK, again, Peter. And then Spiners by Christian Koopman, January 31st. And then Distributed Oracle Agreements. I'm so sorry I cannot see the name because of the Zoom boxes, but on February 15th. And then, yeah, a bunch of links for the meetups. But I'll end here. This is what I have. Thank you all for bearing with me through all of this, and happy to take some questions.
I was going to say, surely the thank you is to you and not thanking us for listening. So that was awesome. The questions. This is a challenge because there's a lot of information there, and it's a lot of. For me, it's something that I thought I knew really well, but then I realize I don't think I know as much about it. Anyway, Frank, over to you.
Yeah, thank you, Peter. Thank you, Tim, for this very informative session. There's a few questions, but let's say one of them is about Ethereum community events. So you haven't mentioned any of them, like EthCC or DEF CON. So how does it work? So my personal feeling is that it's very opaque. For instance, our workshop is decided whether it's going to happen or not, whether a topic is represented. And the selection process or invitation process is very opaque as well. I never know when I submit something whether it's going to someone. Notification that there were too many applicants, and when I look at the talks, I think okay.
That's a good point.
So,
and I think part of the reason I didn't include it is I maybe foolishly like to believe that the events are like not necessary for the process. Like I don't, and I think in practice it's true. Like there's a lot of people who like influence Ethereum in different ways and never sort of show up to events. But that's not to say they aren't helpful. I think the thing with events as well is kind of luckily now there are many different ones with like different approaches. So like you mentioned ETC, and like DEF CON is the other one. Like, ETC operates like a conference completely independently. I have no idea how they choose their talks. I know who organizes it, but that's pretty much it. I think DEF CON, I don't work on the DEF CON team directly, but they're part of the Ethereum Foundation, so I get to spend time with them. I think their view is they want to focus on like one Ethereum mainnet exclusively, and they're lucky in that they don't need to like appeal to anything else, to like sponsors or whatever to like, you know, pay for rent basically. So I think that's like kind of a fortunate position to be in. And I think beyond just Ethereum and Ethereum focus, they want to highlight stuff that they think will be important in the future of Ethereum, but maybe is not getting the attention it deserves today. And you know, one like great example is like there's not much DeFi content at DevCon today because there's like, you know, plenty of DevCon conferences, DeFi conferences. But in 2018, Uniswap launched, and you know, DevCon was like very like there was like a Uniswap talk, and people were trying to explain to people, hey, look, like this is interesting, and no one really cared about it. But now, obviously, you know, a lot of people know how Uniswap works, and DeFi is like evolved a ton. I think you see the same thing, like, you know, if you look at like the early DevCons, they kept talking about MakerDAO and like, oh, stable coins and like collateralization is going to be huge, and no one sort of listened until like 3-4 years after, and then, you know, now everybody's like talking about it. So I think this is why maybe sometimes like DevCon can be frustrating for most applications, because most of the people by definition are working on like some of the problems now. But I think they really try hard to focus on like, okay, is there a way that we can showcase people who like nobody's heard of and or not enough people have heard of. And then the last thing I'll say as well is with regards to DevCon is we tried this new thing called DevConnect like last year, and we just ran it again, where DevCon's like a quote unquote normal conference. There's talks, and those tend to be hard to like go deep in the weeds in. Like if you care about like protocol security, you know, there might be 3 talks about it at DevCon and that's it. So the idea with DevConnect is instead of doing one event, we're going to run, you know, like a bunch of events in parallel, have the EF do some light coordination, maybe organize some events, but actually have the community organize most of the events and like fill up the calendar, and then try to have them be more in depth, right? So you can have a full day event on security, a full day event on, you know, zero knowledge proofs, a full day event on DeFi. And I think that's been like really interesting as well as the space has grown, because yeah, there's just not enough time to put like everybody who does everything on Ethereum in like a 5-day, 5-track conference. But DevConnect, I think, had like 40 or 50 events. It's like if you wanted to go and spend 2 days talking about restaking or 2 days talking about, you know, ZK development, you could. I think that's a bit more scalable. So like, yeah, these events are like super valuable. I don't think they're strictly necessary for like Ethereum's governance. And like, yeah, I think we'll just see more and more like specialization or different niches appear, because it's just less and less possible to fit everybody in one conference with like one stage. Yeah. Yeah. Any other questions?
So Ethereum Core Devs call is at about 2 a.m. local time.
Oh, that's the worst, I know.
Yeah. And I know, because one of the things that I think about at times, you know, is that say I wanted to do an EIP or something like that, and I wanted to, you know, part of it is going to be convincing people.
Yeah.
And then, so I guess the actual, so would it be possible to get an EIP over the line? You know, so say I did Zoom calls or Google Meet calls with, you know, all the client teams, and I chatted with everyone.
Yeah.
Do I need to turn up to the core devs call?
Yeah.
EIP over the line.
So I think short answer is you want somebody championing it to do it, to increase your odds, right? Like, you know, maybe in theory the answer is no if you're like practical about it. I would try to get somebody who can attend not necessarily all the calls, but like a you know, a significant part of them to advocate for it. Yeah, it would make your life easier. I think in general, like I run the calls, but I don't like that they are the way we do things. So 1, the calls are bad for time zones. 2, they're bad for like anyone who doesn't speak English as a native language. 3, they're bad for anyone who's not like willing to like step up and like raise their objection in the middle of like a 40-person Zoom call. And they're bad for people who like don't necessarily think on the spot and are more like they like to read something and reflect and actually, you know, do some deep thinking. And that just feels like a terrible way to like run governance if you just list all those properties. The things they are good for though is like they do provide momentum and like a regular cadence. And because there's not like a single company, there's not like a single, like even like there is a single coordination point, but there's not like a single manager, anyone who can like impose a cadence. I think they're like a net benefit still because we you know, we get like momentum out of it. I have been trying to move stuff more async. I'd like us to do it more and more over time. And I think it'll be more and more possible as the speed at which we need to go is not like our main constraint. So now we have, like, I've been trying to use ETH Magicians more to have these threads where people can come and like post, you know, their thoughts on stuff and like aggregate their thoughts and like have them in one place. And at least even like say, I don't know, say you can make the call, but then you can take, you know, half an hour to write like an explanation or something. We can actually reference that on the call and you know, give you maybe like a slightly better chance of like getting your EIP in. So I don't think we can like fully move async everything overnight because we'd lose a lot of like the momentum and we're already, you know, quite slow to ship stuff. But yeah, I think the calls are really suboptimal, and especially if you're in Australia.
Yeah, but that's okay.
Yeah.
Having the call change to different times of the day also doesn't work as well.
We've tried that, and it's the worst. Because imagine you wake up at 2 a.m. to go on the call, but then the person in Europe hasn't. They forgot, right? Like this has happened to me. That we tried it for about 3 months and we stopped because it's like somebody's up at 4 a.m. trying to argue for something, and then the person for whom the call's at 2 p.m. literally forgot. Like the 14 UTC is like, at least now it is like seared into people's minds. And also, so one thing, it doesn't follow time zones, right? Like it's UTC based, so that's also kind of annoying. But it's the least worst time we found. But the fact that we have to rely on a synchronous time is really not great.
Thank you. Are there any other questions?
Got one last question, maybe. So, how can I put it? For instance, the name, right, of the center of the onion, which is the core devs, has devs in it. So there's some emphasis on people who would write code and so on. And I think that's a strong taint in the Ethereum community. You mentioned, for instance, the Ethereum execution layer specification. It's an implementation in Python. It's not a specification. But so there's a strong taint of programming and developing and so on. So would there be any benefit in having a sort of a community, inviting in the community other people who are contributors, but at a different level? So I raised this issue, for instance, because, personally, we worked on a formal specification of whatever, the EVM and so on, and the Ethereum Foundation pushes the specification in Python. It's not language agnostic, it's an implementation. So there would be a debate around this. What's the best thing? Could two different things coexist and so on? But it seems to be very again opaque. How to get in, not only for the time zones, but how do you get invited? How can you share your opinion? And
so how to get invited to the actual calls is on we have a Ethereum/PM repo. There's actually instruction there, but like if you want to get to the call, I think that. But the more substantive questions like the dev bias, I think it's true. I do think though this is good because Ethereum historically is like biased towards research ideas that are impractical, and we've had many cases of like coming up with like some research solution where we just have implementation details left and it all falls apart. So I think, and we do have a bunch of researchers show up in awkward devs calls. Like they, I wouldn't let the name like stop you from coming. But I think framing things in terms of like actually writing the software probably counterbalances a lot of the like overly intellectual slash I wouldn't call it academic. I don't think the research we do is like particularly academic in style, but like we are like research heavy. Like if you look at someone like, Vitalik's like the clearest example of this, he is someone who like thinks in like ideas and concepts and whatnot. And then like, then it's all sort of an implementation detail after that. So I think having the call all core devs is probably good. Having the Python spec, I agree, like it's opinionated and whatnot, like, but it sort of biases in the way of like, okay, we have to write something that actually compiles. Formal verification, I suspect that the challenge people would have is just like the barrier to entry, which is similar to the yellow paper. I think it's just like people feel like it's easier to read. More people can read and write Python than can read like the yellow paper. But everyone who's like not from a development background argues around that. And then I think the other thing we have that's kind of neat, like ETH research, I think is like a very valuable resource in the community. Like the amount of just new ideas and like, again, I would call it academic, but academic-esque debate that happens there, I think is quite valuable. And there's also a bunch of academic papers that do, and like the EF has been collaborating more with like places like Stanford. There's literally an event happening with Columbia tomorrow. So I think there are more and more academics interested. And frankly, for a while, a lot of the academics just hated blockchain, right? Like, so I think for a while, it's like, we probably wanted to, and then they just like didn't reply to the emails. And it's been good to like see more and more of academia actually care about this stuff. But yeah, I think we'll always have probably like the client development process be biased towards developments, just because otherwise we end up talking about ideas that will never be practical. And again, we're so slow as a baseline that anything that can bias us towards like writing code that goes to production is probably worth keeping in the process. Yeah, sorry, that was
So I
very
think academics
answer.
have well, there's lots of things going on in academia. I mean,
Yeah.
Recently, Peter, you may also mention that there was a conference in Sydney, in Brisbane, sorry,
Yeah.
SDLT. There are lots of top-tier academic conferences that have been including in their call for papers, blockchain stuff. I published in several of them recently. There's lots of people from Stanford, the Move language, for instance, or other things. Consensus algorithms, Red Belly network in Australia, and so on. So I think the community, the academic community, is very interested in this topic. And but there's two communities, basically the Ethereum somehow, practical applications, and the academic conferences. So how to make this happen together?
I think some of them, I think some of them have done like a better job. Like the most obvious example is like Dan Bonet's work. Literally, is how we do signature aggregation on the Beacon chain, right? Like I think he's an example of someone who like obviously is like an academic. Like he's never written client code for like proof of stake, but it's like he was able to do the work, and like it somehow made its way to like a major change. I think the other place that I would argue there's a ton is like everything around Starks, right? Like StarkNet is like
I was going to tell you, Stark is right. It's a good example of
and I'd say maybe the biggest challenge I find working with academics and like is a lot of times academics have they work in a certain background, and then they see a problem on Ethereum and they try to map that problem to their field and like come up with a solution within their domain. And then the solution doesn't quite like fit right with like Ethereum. And I think the people who've done like the best work are people who've like managed to think of like approach something. Obviously they have an expertise, they have a background, like they, and use that, but like approach the problem as it is in the practical way that it's framed for Ethereum. Maybe one like amazing paper that I really like and got to help fund is Tim Roughgarden's analysis of EIP 1559. So he has this like 30-page paper analyzing like the soundness of the mechanism, and he does it in a way that actually maps to like the real constraint, not like the mechanism in the abstract, but like the mechanism as it would be deployed on Ethereum. And it like significantly changed the community's willingness to adopt this. So to me, that was an example of like somebody like, I mean, he was like a professor at Columbia trying to understand this like on its own terms, and then writing a paper that was super impactful. And, you know, like it wasn't like a novel contribution to the mechanism, but it was more like we had this mechanism designed by like engineers. We felt like it would work, but we didn't have like a formal proof that it was economically sound, and he like provided that, and that was really valuable. So I think, yeah, this may be the other thing where like if there are specific problems, having academics solve them in the context of like the Ethereum mainnet, and not like making a bunch of simplifying assumptions like, you know, if only we didn't have like adversarial actors, then, you know, we can use this mechanism. It's like that work is maybe useful in other contexts, but like a lot of it will never be like applied on Ethereum. And another thing as well, like for like cryptography, I think this is the thing where some of the newer academic constructions, it's like, have they been proven to the, like, how sound are they, right? Like, and for stuff like cryptography, it tends to take like a really long time to just build the confidence. And recently there was a bunch of stuff around like VDFs where, you know, we thought it was safe, but then turns out there's an issue. So this is also why like there's like a lag, right? Like I think we're just like pretty conservative in terms of what we implement on the Ethereum mainnet. So sometimes somebody comes up with like a new idea, and it, you know, it might be a good idea, but if there's like some tail risk that we just can't validate, yeah, we probably won't ship it on Ethereum.
Yeah, look, I think that makes sense. I mean, especially for cryptographic algorithms, they can take, you need to put it in a standard and then wait 5 years for someone to get around to finding a bug in it, writing their PhD thesis or an academic paper, and then I think, I mean, my finding though is I've worked with a lot of academics, and I think part of it, the issue is, as well as them having their background, is that they're so busy, and Ethereum and blockchain generally is moving so fast that it makes it really hard for them to have, you know, like knowledge that is current. Like I was recently where someone was talking about plasma and payment channels, and I'm thinking, ooh, you know, that's like that's ancient history.
Yeah, I think this. Yeah, you see this happen a lot. So there's like two versions of this problem. One is they just like don't have the current knowledge. This is like fixable. I think the other challenge I've seen academics do is they like say they take something on plasma, they go on a quest for 2 years. Like they you know, this is like 2019. Plasma is like the peak current knowledge. They learn all that, and then they like go on a quest for 2 years, and they don't like keep updating their knowledge during that. And then they come back 2 years later and they've solved something on plasma, but it's like, okay, you know, nobody's using plasma anymore. And look, this is a hard problem. Like there's like this trade-off between like, you need to do deep work and these problems are really hard, and then like there's so much noise in the community. But I think this definitely happens where it's like you see novel contributions to problems we had 3 years ago. And like it, again, from like some theoretical point of view, like it's still valuable to do that, but then like Ethereum mainnet is just not gonna do it because we've moved on to something else. So it's it is like a hard field to engage with, for sure.
Yeah.
All
right, we've been going for 1 hour and 9 minutes since the start of your talk, and even longer if we include prep time. So thank you for your time today, Tim. That was awesome. And have a great week. And thank you.
Thanks everyone.
Thank you, Tim. Thank you.
And by the way, I'll put one last academic recommendation if people want to look. But there's a bunch of stuff around timing games in proof of stake right now. This is like the hot new thing. How do we handle people messing with the time ordering? So there was just a really good post on ETH Research today on the topic, but this is a field where there's probably tons of work to do to figure out what are practical bounds and constraints we can add. yeah. So if you want to go down a rabbit hole, I think this is a really valuable one.
The latest valuable one.
Yeah, yeah. There's many other ones. Yeah, but yeah.
All right.
Cool.
Thank you,
Well,
everyone. Talk later. Bye-bye.
Thanks, everyone.
Thanks,
Cheers.
Tim, for a great talk. Bye.
Bye.